you, lovers of mathematics, for stopping by. I am Tutor Cletus Okole. We have an exponential equation on the board to solve. Kindly watch to the end, and I believe you will learn something. Meanwhile, subscribe to my channel if it is your first time of stopping by. Like my videos so that YouTube can recommend it to more people. We dive into the question, and it is given to us as a solution. We put it down: 3 raised to x plus 3 raised to power 2x equal to 3 raised to power 3x. It is a unique type of exponential equation because all are appearing in base 3, and also the powers are moving in the increasing order. Alright, I want to quickly rearrange the values such that I want to move everything from the left hand side to the right hand side. And when that happens, what I will now have, writing what I have by the right hand side first, which is 3 raised to power 3x. Then moving this to the right hand side will give me negative 3 raised to power 2x. Moving again, 3 raised to power x to the right hand side will give me minus 3 raised to power x. So right now, by the left hand side, nothing is left, so we put 0. Now, from this question, what I have to do next is to factor what is common. And looking at it, 3 raised to power x is common because we have 3 raised to power x virtually in all of them. And this is going to be for me 3 raised to power x. Then the first expression will now be 3 raised to power 2x, because here is raised to power 3x, so raised to power 1x is outside. Here we'll be left with a minus 3 raised to power x, 1x is outside, and here we'll be left with 1. Since what I have here is 3 raised to power x, so having factored 3 raised to power x outside, what I have left here is 1. Everything now is equal to 0. What this thing means is that 3 raised to power x is equal to 0, and the second one, 3 raised to power 2x minus 3 raised to power x minus 1 is equal to 0. But from this first part, you can agree with me that 3 raised to power x cannot be equal to 0. The reason being that if I have 3 raised to power x equal to 0, assuming I take log to both sides, okay, 3 raised to power x equal to log 0, and you know that this is math error. You cannot code. Therefore, the solution cannot be possible. Therefore, we move on with the second bracket, which is now 3 raised to power 2x minus 3 raised to power x minus 1 equal to 0. That is where we move on with. Then, looking at it, I have this 3 raised to power 2x minus 3 raised to power x. Let 3 raised to power x be equal to y, okay? But also in indices, if I have something like maybe a raised to power 2x, this thing is the same thing as a raised to power 2, then multiplied by x. It is also equal to a raised to power x multiplied by 2. So by this, I can still write it as a raised to power x or raised to power 2. What I'm trying to say in other way, in essence, is that since here I have 3 raised to power 2x, I can write it as 3 raised to power x or raised to power 2, then minus 3 raised to power x, then minus 1 equal to 0. But I have already said that 3 raised to power x is equal to y. Therefore, I can now have 3 raised to power x, which is y, raised to power 2, then minus 3 raised to power x, which is now y, also minus 1 equal to 0. At this point in time, it has become a quadratic equation. What it means is that after I have found the value of y, I can now come back to this place and substitute the value of y to know what the value of x is, because I am evaluating for the value of x not the value of y. Alright. Now let us use quadratic formula to apply to this quadratic equation. And that is going to be, quadratic formula says that minus b plus or minus, then the square root of b squared minus 4ac all over 2a. This is quadratic formula. Alright. Here, my a is equal to 1, the coefficient of y squared, and my b is equal to negative 1, the coefficient of y. My c is equal to negative 1, which is the value without a variable. Substituting into the quadratic formula, I will now have my y equal to b minus 1 plus or minus the square root of minus 1 squared, then minus 4 multiplied by a, which is a 1, then multiplied by c, which is negative 1. Everything here divided by 2 multiplied by 1. Okay, that is where we are now. This is now going to give us, okay, let's put it down more. Y here will now be equal to minus is 1 plus or minus, then 1 squared is 1, then minus 1 times 1 here will give me plus, 4 times 1 is 4, then everything divided by 2. That is where we are now. Meaning that I will now have next my y as equal to 1 plus or minus the square root of 5 all over 2. I have gotten the value of y. This implies, if we want to separate it, it will now be y is equal to 1 plus square root of 5 all over 2, or y is equal to 1 minus square root of 5 all over 2. But at this point, we have said already that 3 raised to the power x is equal to y. So if we here make our y to be equal to 3 raised to the power x, 3 raised to the power x equal to 1 minus square root of 5 all over 2. This particular one also cannot hold because here it cannot be negative. So the negative part of the value of y cannot hold. So we move on with the positive part, which is y equal to, let from y equal to 1 plus root 5 all over 2. Now, anywhere we see y, we put 3 raised to the power x. I can now write that 3 raised to the power x is equal to 1 plus square root of 5 divided by 2. From here now, I can now work on to get the value of x. And what I will do next is to apply logarithms to both sides. And applying that logarithms, it will be a logarithm to base 3. So that I can be able to get x to the left hand side alone. What that means is that I will now have next the log of 3 raised to the power x to base 3 equal to the logarithm to base 3 of 1 plus root 5 all over 2 together. This is where I am now. By law of n logarithms, if I have the log of a raised to the power x, it is actually equal to x then the log of a. Applying this law of logarithm to the left hand side, this is now going to give me x then the logarithm of 3 base 3 equal to the logarithm of 1 plus root 5 over 2, then everything to base 3. Also, the logarithm to its own base is equal to 1. That is, log a base a is equal to 1, meaning that log 3 base 3 should be equal to 1. So I will now have here x multiplied by 1, which is equal to x. Therefore, what I will now have next, since x times 1 is x, I will now have x equal to. At this place, I can apply change of base in logarithms. That means if I have the logarithm of a base b, I can still write it as the logarithm of a all over the logarithm of b. Alright? So applying that here, it can now be written as the log of 1 plus root 5 over 2 divided by the log of 3. and at this time it will assume the natural base, which is base 10. Alright, now let us now move on to get the final value of x. I can now make use of calculator at this point in time, and from the numerator I will now have the logarithm of 1.6180, and that is square root of 5 plus 1 divided by 2 will give me 1.6180. Then divided by the logarithm of 3, and the logarithm of 3 is 0.4771. This means that I will now have, if I press it in my calculator, the logarithm of 1.6180, I am going to get log of 1.6180. This is now going to give me 0.2089. Okay, 0.20897 divided by 0.4771, meaning that the value of x now, when the division is taken, okay, this is now going to give us 0.4382 3 decimal places. So, in conclusion, the value of x here, after simplifying everything, is equal to 0.43823 decimal places. Thank you for watching this video to the end. Remember to subscribe to my channel if it is your first time of stopping by. Also, like my videos. Thank you for stopping by, and thank you for watching to the end. God bless you.